Hello, welcome to this edition of the Henstitute, where we talk about Chapter 1, Scalars and Vectors. And I decided to put a picture of Vector here. If you've ever watched the movie Despicable Me, then you're familiar with him. And he actually does a great job in the movie of explaining what a vector is. Scalars, for us, are any quantities that only can be described or only need to be described by a single number or a magnitude. Temperature is a great example. If I say that the temperature is 78 degrees Fahrenheit, that's all I need. There's nothing extra that gets added to it. Vectors, on the other hand, if you actually watch the movie and listen to it, they're quantities that have both magnitude and a direction. The one we're going to start off with in this section are displacements. Displacements don't just say how far you went, they also say what your direction is. So if I say that I traveled 50 miles, so if you watch the movie, like I said, Vector does a great job of that. We continue in that movie. He even mentions that it's usually represented by an arrow. And the reason why we use arrows is it allows you to show direction really well. Plus, the length of the arrow can indicate it. So 8 meters is larger than 4 meters, so we make a larger arrow. This is a great example. So this is a displacement vector. We know that this car traveled 2 kilometers, and then we've got this 30 degrees over here, and we know north, south, east, and west. So I would argue that the displacement of this car is 2 kilometers, but that's just the distance it traveled. And then we would say at, so that's saying something about its direction. The 30 degrees helps me out because this line is representing east, and you start at this east line and you measure up from it or north of it, and so I would argue that this is at 30 degrees north of east. Put that all together and there's your vector, there's your displacement vector. So that's one of the things we're going to get into. Sometimes you have to combine vectors together. You just have to be able to combine them together, add them, subtract them, that type of thing. I like to just use the word combine them. You'll see a little bit why. So the common method is the tail to head method, where you put the tail of one vector right at the head of the other vector so you can combine them together. We do that if we have simple questions like this. What's the result of 5 meters east and 3 meters east? Well, if I wanted to find this, all I'm going to do is I'm just going to put them back to back. So there's my 5 meters east, and then from there we're going to pick up with the next one, and there's my 3 meters east. The result of these two vectors, or the sum of these two vectors, would be 8 meters east. Pretty straightforward, nothing too fancy there. However, the concept of subtraction pops in, and the real reason why that does is because if you take a vector and you multiply it by -1, it actually is the same magnitude, but the direction of the vector gets reversed. If you remember in math class, a negative actually was the opposite function. So that's what's really happening here. So I could draw this picture right here and say vector A heading towards the east, for example, and then from the tip of that, or the head of that, I'm going to draw the next vector, which is vector B, gets up here, and I could say the sum of these two vectors is vector C. So it starts here and it finishes there, and this is vector C, for example. And we draw like this, even though it's not just the sum of the two numbers, it's the vector sum. However, if I rearrange that by subtracting B to the other side, I should be able to say that A is C minus B in terms of vectors. What I'm really doing is I'm saying that minus B vector is the same magnitude, it's the same length, but it's now in the opposite direction. Notice it's pointed kind of towards the southwest, whereas the B vector was pointed kind of towards the northeast. So that's what we've got. We're going to use that to solve questions like this. If I took the result of 5 meters east and 3 meters west, I could draw that out, but another way of thinking of this is 3 meters west could actually be thought of as -3 meters east. where the negative sign here just reverses the direction. Now when I try to combine it together, I'm going to start here. So here's my start, and then I go 5 meters east, and then I say that from there I'm going to go back 3 meters. So in other words, I'm going a negative 3 meters, or I'm going 3 meters west, and then my result would be this little vector right here. So this is the combination, or the sum, or the subtraction between these two vectors. Great when you're dealing linearly, but what happens if we're not? What if we have 5 meters east with 3 meters north? Now what do I actually have to do? Well, to find this type of stuff, I'm going to start creating a triangle. So that's why we did all this triangle math, because if I have vector A that's pointed towards the east, and then I have vector B that's pointed towards the north, I can't just simply add the two numbers together. I'm going to have to make a triangle out of these to find this result. And some of the things are going to be really nice. So if I have 5 meters east, like I just mentioned, here's my east, here's my north, I should be able to find this resultant vector, and I can start that off by using Pythagorean theorem. And the hypotenuse squared, the magnitude of r, would equal the length of one side squared plus the length of the other side squared. So c squared equals a squared plus b squared. Kind of continue from there, and we get the magnitude of r would be 5.83 meters. So to get from start down here to finish up here, we are going to go that far. So we're not going 8 meters. We are just 5.83 meters away. The other part is I have to give a direction to this. So I can't just simply point out that I have gone this far. This is just my magnitude. I also need a direction. So the angle is here is perfect. And I always like to do it around where you start. So I always want to find the angle around my starting point. I like using tangent because I'm positive from the original problem that it's 3 and 5 meters. That allows me to find the angle by using the inverse tangent of the opposite over the adjacent, and that gives me my 30.96 degrees. So this is 30.96 degrees. But I'm not done. There's a little more I need to do when we talk about vectors here in physics class. Is I look at my picture. I'm starting here at my east line. So from my start, I went east first. So this is my east line, and I'm going to measure up from it, or north of it. So that's where I get my 30.96 north of east, just like I was describing earlier about this car that was traveling north of east. So the final result is a vector that has a magnitude and a direction, where I would say it's 5.83 meters at 30.96 degrees north of east. And this gives me my full combination of these two vectors. And that's one of the things that we want to be able to do as we get into describing motion. Hope you enjoyed this edition of the Henstitute on scalars and vectors.